I'm in Mastercam X7. The next assignment is to design a truss using the CAD software of your choice. This is a CAD portion of Mastercam, or you could draw it in Inventor. The span of the whole truss is 32 feet, and the pitch of the truss is 6 and 12. So let me show you how to go ahead and draw that. So this is what it's going to look like when I'm finished. And then we're going to use parallel lines cut by a transversal to show how to find all the angles in the given truss. Okay, we're going to create a Howe truss, a very common truss, invented probably 150 years ago for railroad bridges. It's a great way to build a truss, pretty simple. I'm going to do a span of 32 feet, so I create a line starting at the origin, and I'm going to go over 32, up 0 degrees. There's my first line. Next, I'm going to create the center post going up, so that's going to be a line. I snap on my midpoint. I want to go 8 feet up, and the way I got 8 feet and 90 degrees, the way I got 8 feet is the pitch is 6 and 12. So it rises 6 for a run of 12. So I set that ratio as 6 and 12 to what in 16. So 6 is to 12 as 8 is to 16. So ratio equal to ratios of proportion. I'm going to draw the roof line in here from the ridge back to offset. The point. The total distance is 32. This is 16. So I'm going to offset 8. Offset 8 that way and that way. And then I'm going to trim this line back to here, this line back to here. There's my clear colors. That's basically my truss, and then I need these triangular supports. So I'm going to create 2 more lines from that point of intersection to that point. And from here. Now, I know a 6 and 12 pitch, or 8 and 16. I could use a tangent of what angle equals opposite over adjacent. Solving for that, I go arctan of 8 over 16, arctan of 0.5 works out to be 26 degrees. I'm going to create a dimension, an angular dimension. Tangent of the angle equals opposite over adjacent. So tan of theta equals 8 over 16. Tan of theta equals 0.5. Divide both sides by tangent. The arctan of 0.5 is 26.5 degrees. And that's where that angle right there comes from, 26.6 degrees. And then now that I have this angle, I should be able to figure out every other angle in this truss using my knowledge of triangles and parallel lines cut by a transversal. So go ahead and find all these angles in this whole truss member, and then when you're done, check to see if you have them correct by using the dimension function. So I'll give you a second to see if you can figure these all out, and then I'll go through and you can check your answers to this drawing. So create a drafting dimension that's angular. I know this to this is 90 degrees. This to this is a complement of 26.6 degrees. So that's going to be 63.4. And there that is. Then this angle to this angle, well, let's see, if this is 26.6, this right here is also going to be the same. This is an isosceles triangle, so these base angles have to be the same. To right triangle, so this is a complement at 63.43. This angle right here is the alternate interior angle of this. So if I look at a parallel line, cut by a transversal, this angle and this angle have to be the same. And when I put my dimensioning in, I could see that they are. Then I could actually tell that this is an isosceles triangle. So these two angles have to be congruent. And they're also going to be the supplement. The sum of them is a supplement of 63. That works out to be 53. And this will be 53 as well. And then all these angles will all be the same. So a little knowledge of right triangles. All 3 angles add up to 180. Right means 90, so 2 have to be complementary, adding up to 90. knowledge of parallel lines cut by a transversal, you're able to figure out every one of the angles in this truss.